This video is a review of linear equations in two variables. We'll start with the definition. A linear equation in two variables can be written in the form ax plus by equals c. Here, a, b, and c are real numbers. A and b cannot both be 0 at the same time, and x and y stand for the variables. Solutions to this equation are ordered pairs, that's an x and a y, that make the equation true. Now there are infinite solutions to a linear equation in two variables, and when all of these solutions are plotted on an xy plane, they form a straight line. Now a straight line has a certain incline, and if we measure that incline or the steepness of a line, we call that the slope. The slope is also thought of as a ratio of the vertical change to the horizontal change, and we can represent that symbolically. The m stands for slope, and the change in y represents the vertical change, and the change in x represents the horizontal change. Now, if you have two points, you can find the slope or calculate it using the following formula. M equals y2 minus y1 divided by x2 minus x1. So you see in the numerator here, that's what gives you the vertical change when you find the difference in the y coordinates. And when you find the difference in the x coordinates, that gives you the horizontal change. Now the actual value of the slope can be different. The slope is a rational number. So that could be positive, it could be negative, it could be equal to 0, or it can be undefined if the denominator becomes 0. So this just gives you a summary of everything that can happen with a line. And the first case is when the slope is positive or greater than 0. This will give you an increasing line. And we read a graph from left to right. So we say this line is increasing if it's going uphill as you go from left to right. The next case is when you have a slope that is equal to 0. That gives you a horizontal line, which is not inclined in either direction. In fraction form, the numerator of the formula will be 0. The third case is when the slope is negative or less than 0, and that will result in a decreasing line that goes downhill from left to right. The final case is when the vertical change is 0, so you have a 0 in a denominator. That gives you an undefined value, which means the slope is undefined. So again, that results in a vertical line because there is no change among the x coordinates. Now, it's important that you say that the slope is undefined, not that there's no slope, because that can be misinterpreted as a slope of 0. Now, there are several forms of equations of lines, and we'll talk about each of those forms. The most popular one is the slope-intercept form. This is the one that's most useful, or the first one that you think about when you want to graph a line by hand. In this form, you have the equation y equals mx plus b, where m represents the slope and b represents the y-intercept. The next form, or the next way you might see an equation written, is in point-slope form. This is particularly useful when you are writing your own equations of lines based on some given information. Here, the x1 and y1 is any given point on the line, and m again represents the slope. Now, any horizontal line can be written in the form y equals b, where b here is just a real number, and that real number represents the y-intercept. Vertical lines are in the form x equals a, where a is any real number, and a represents the x-intercept. Next, we'll talk about parallel and perpendicular lines. Now, if you have two lines that are known to be parallel, you also know that their slopes are the same because they're moving in the same direction and they are not going to intersect. If two lines are not parallel, they do intersect. But if they intersect at a nice right angle, we call them perpendicular. And perpendicular lines are special in that their slopes are negative reciprocals, which means that the fraction is flipped upside down and the sign is changed from either positive to negative or negative to positive. Now, another important thing to note is that a vertical and a horizontal line are considered to be perpendicular, which also means that all vertical lines are parallel and all horizontal lines are parallel. So next we have some examples. These are just 5 different questions that are requiring you to write an equation of a line in slope-intercept form. So my suggestion here is to pause this video, go through each of these 5 questions, write equations for each of them in slope-intercept form, that's y equals mx plus b form, and then when you're done, go back to the video and you'll see these solutions. Okay, so I have these solutions done for you here. Now, in the first case, you are given 2 points. The first point was given as 4, -3, and the second point was -1, 7. I'm just going to label these x1, y1 and x2, y2. That will help me to find my slope. Remember the slope formula, y2 minus y1 divided by x2 minus x1. Plugging in the values that I have from my labeled points. And then I can simplify the numerator. Here I get positive 10, and then the denominator I get -5. Overall, that gives me a value of -2 for my slope. Now we can go ahead to the point slope form. Now I'm plugging in the point that I've labeled, x1, y1. I could use the other point, but I've already have it labeled. And I'm also plugging in -2 for m. After I make a substitution, I'm just going to simplify and solve for y. So I'm distributing that -2, subtracting 3, and I get y equals -2x plus 5 as my equation. In the second example, we are given a slope. Our slope here is -2/3, and our point that was given was 9, -2. So here we don't need to calculate the slope, we can go right to the point slope formula. Remember, I'm substituting in for x1 and y1 only, y and x stay letters y and x. Also be careful that you may have some double negatives like we do here. So that becomes y plus 2 equals -2/3 x plus, and that gives me a positive 6 when I multiply -2/3 by -9. Once again, solving for y, we get y equals -2/3 x plus 4. Notice that the slope has stayed the same, -2/3. In the third example, it's slightly different. We were told that the slope is undefined. The point that we want to pass through is 4, -6. Now, an undefined slope means that our line is vertical. So a vertical line is of the form x equals. We just have to figure out what is x equal to, and since this passes through that point, we take the x coordinate of that point to find our x-intercept. Number 4, we're told that we want to be perpendicular to the given line y equals 2x plus 5. All we care about this given line is the slope. The slope for that given line is 2. We also want to pass through the point 4, -2. So there's the slope of the original, which means the slope of my new line will be -1/2. That's a negative reciprocal. Plugging each of these pieces of information into my point slope equation. I have y minus, that should be y minus -2, fix that, equals -1/2, oh, I wrote an m by accident, I'll fill that in, So it becomes y plus 2 equals negative 1/2 x minus 4. Now we'll go ahead and distribute that negative 1/2. That becomes negative 1/2 x plus 2. And now here I have plus 2 on both sides, so those cancel each other out. I'm left with y equals negative 1/2 x. So that is my equation. Notice that there's no y-intercept written, which means it is 0. Alright, the final example, we're told that we want to be parallel to the line y equals 8, and also passing through the point negative 7, 13. Now this is a horizontal line, and since I want to be parallel, I'll also get a horizontal line. So I'm writing y equals, and then I just take the y coordinate of the given point to get y equals 13. Alright, so I hope you enjoyed the review of linear equations in two variables. Please feel free to email me if you have any questions or leave it in the comment section of the video.